Hello, everyone. Dusty from NVIDIA here. Super excited to be back. We thought this would be a good check-in office hours type session for anybody interested in deploying the latest language models, vision transformers, vision language models, all of the Gen AI related stuff that we've been working on and putting out there in the community. So we kind of just wanted to keep it like open chat, AMA style type of things. And I also have a bunch of demos and latest stuff to get you guys all caught up on. So yeah, really looking forward. Thank you to everybody who's joined us today here. So just a couple housekeeping items before we dig in and get started. And by the way, feel free to enter questions into the chat at any time. I like to see them come up in my feed here and would like to keep this interactive. But a couple of housekeeping items before we really dig in and begin. Is Jetson joining? I wish so, but not. He is probably just as busy as everybody else getting ready for GTC, which is in just a few weeks and is very exciting because it's the first one that's been back in person since pre-COVID. I haven't even traveled for work in several years now since before that, and we're all just really amped to. It's a big community meetup essentially, and everybody that's really into GPU computing is there, and it's going to be really exciting. So that is March 17th. Let me screen share some of the awesome stuff that we have going on there. Let me see which of these views is the best. Probably this one. Let me get this off your feed there. We'll get to this demo in a little bit here. But yeah, GTC it is both virtual and in person. So obviously, if you're in the Bay Area or whatnot, highly recommend to come out and at least to see Jetson's keynote, which is always super mind blowing and amazing. But it's in just 2 weeks, and if you can't make it in person, there's all virtual sessions and stuff. But excitingly, we also have a bunch of these hands-on DLI labs from the Deep Learning Institute that myself and my teammates are putting on that will basically run through all of the latest stuff that we've been working on the Jetson AI Lab and otherwise. And we will have physical Jetsons there. Everybody will have a Jetson AGX ORAN to work on. And there's ones on Isaac Sim. There's ones on Metropolis microservices for Jetson. There's this cool one training a race car driving model in Isaac Sim and then deploying it on the Jetson with hardware in the loop. So there's a lot of really awesome ones. I'll be giving one that essentially is a glorified walkthrough of the Jetson AI Lab and covers all the different ways to run Llama, run Lava, basically going from deployment or going from you hearing about a cool model, seeing it on Hugging Face, all the way through deploying it to the most optimized path. And so if you are able to make this, we highly recommend these lab style courses where I'll be up in front and literally going through this stuff together. And even if you've never played around with LLMs or chatted with them yourself on your own machine, it's really fun and it's a great time. And then on that Thursday, we also have a special Jetson Developer Day that is very focused on robotics sessions, high performance vision, edge computing. And there is a reduced price for students and others that day. So you can only attend that day. This Thursday is really good if you are into Jetson stuff. Let me get caught up on some of the chat questions here real quick. I see Brian join us. Thank you very much, guys. So here's a good question. I have a 2018 AGX Xavier coming in the mail in 2 days. Is that too old for running LLMs? And the answer is no, it is absolutely not. And as we'll see here, there's many ways to run LLMs. If you're fine with, normal performance, you can just go on to the Jetson AI Lab and pull the Hugging Face text generation web UI container, which is the Ooga Booga is the most popular web UI for running this stuff locally and supports so many different model loaders, they're called, which is essentially inferencing APIs and model formats transformers, llama.c++, AutoGPTQ, AWQ, X Llama, the list goes on and on. However, it does not support some of the highest performing ones out there. But this is where like your journey with model deployment will always begin. You always want to try it first, pre-quantization, go in here and like mess around with it, get a feel for it, put in some test prompts to see if it adheres to like what you need it to do before really spending any time on it. And yes, this will run on Jetpack 5 and AGX Xavier because it's not, so the packages in here are not always requiring the latest and greatest performance. Some of the newer ones that I use in the demos, the interactive ones for the highest performance, like this MLC TVM project, which is like a really cool project out of CMU Catalyst Lab that does all like edge LLMs, even on phones and in browser stuff. And Jetson very uniquely like kind of fits into both worlds. We're both in like high performance computing and also edge computing. And I've been using this to get like the highest performance possible out of things, which you can see on the benchmarks that we provide here. But long story short, a lot of the latest bleeding edge stuff has moved on past what can be provided in Jetpack 5 and Ubuntu 20.04 and Python 3.8. So everything's on like Python 3.10, Cuda 12.2, Ampere GPU architecture. That's the other thing. With Xavier, that was Volta and SM72, and a lot of these like optimizations, these high-end optimizations in here are only applied to Ampere and the SM80. So if you want like the absolute greatest bleeding edge performance, the answer is no. If you're cool with messing around with other tools like Ooga Booga, or there's many others as well that still, you can still do quantization. You can get better performance like with the llama.c++ container. This is my go-to for if I want to run models in Ooga Booga. This will get you like decent performance. And there's a lot of these pre-quantized GGUF models on Hugging Face. And if you're not familiar, like when I talk about Hugging Face, it's like just this huge model repo built around Transformers library. And you can go on here and search for different models that you want. Like, oh, I want to take the Phi2 model, but I want to find the quantized GGUF version that is able to be run through llama.c++ at an accelerated rate. And the bloke, who's like a very prevalent guy in the community, has put out tons of these quantizations, which you can also run yourself. These are very easy, especially if you have an AGX Xavier or AGX O-ring with 64 gigabytes of memory, which will run practically anything. And those AGX O-rings with 64 gigs are really nice because they have more memory than a lot of like discrete GPU cards, and we can run full-on Llama 70B without issue on them because of that huge memory. Much like if you follow like the local LLM Reddit, there's a lot of Mac M.2 Studio Pro users or whatever on there that they really like that large unified memory system. But long story short, all the benchmarks here are with MLC currently because it gets like the best performance and does quantization. To put it in perspective, there's another page on here where I break down the difference between, I think this one I show it. Yes, this tutorial goes through all the different ways of deploying Llama, starting with transformers, going to llama.c++, and so on and so forth. And you can see the performance difference that you get here. If you just load it up stock through Ooga Booga, you'll get like 2 tokens a second. And if you iteratively go faster and faster through faster APIs, llama.c++ will give you 10 tokens a second. Whereas the MLC API will give you 21. So it is like quite different. And for just LLM-based chat, it's generally fine to just do like interactive rate, like with this Llama Speak demo I have here where you're like verbally chatting back and forth. As long as you can meet like 10 tokens a second, that's generally fine. As long as you don't have like other stuff. running on your processor. But when it comes to the vision language models, which we've started to run live on like real feeds continuously, those like every token per second matters because you want to get it as fast as possible, which is really why I've been, optimizing for months and months now just to continue in improving that performance. And recently we made a new page that further breaks down all of the processing for vision language models. Obviously, most Jetson systems have cameras attached to them, and they would lend themselves well to vision language models. There's a good comment about here. He's like, yes, it is more tokens per second and it's quantized. In that chart that I was showing, it's interesting because just because it's quantized doesn't actually mean it's more tokens per second. In the first example here, we're using 4-bit GPTQ, but it's actually slower than the unquantized FP16 version because some of these unoptimized implementations, the 4-bit math is actually slower than the just stock FP16. And this was notoriously the case when Transformers library used the bits and bytes, which is like one of the first quantization libraries out there with the load in 8-bit flag. It was way slower than if you used it not. But the whole point was to save memory because anything possible to get to the memory. Now there's a load in 4-bit flag that uses auto GPTQ quantization, and that is actually slower than just FP16 through Transformers. Transformers is great because it will run everything. There's so many models in there. It's like the de facto library that like all models are supported in. It's closely bundled with the Hugging Face hub. So like basically every model on the hub has an implementation in here. It's like the vanilla implementation that everybody is working off of, but it's slow as glue essentially, and everybody uses other things for deployment. The discussion about the quantization is important to point out, and in general for like these real world back and forth demo things, I don't see much degradation whatsoever with going to 4-bit quantization or 16-bit versus the original. The more rigorous academic research oriented folks have come up with various quantization methods that are vastly improved, such as AWSQ, which this new VILA vision language model it was trained on to use. And a lot of this is done with the collaboration that we have going on with the Han Lab at MIT, led by Song Han, who is jointly works for NVIDIA also. And let me pull up this AWSQ GitHub here. Okay, activation-aware weight quantization. So AWSQ has much higher quality quantization in it versus like what you would just get on llama.c++ or whatever. Because running those GGUF quants, it doesn't take that long. We're talking like on the order of minutes, maybe an hour if you have a slow machine. And it has started to actually use data sets during the quantization, but they're quite minimal. AWSQ, on the other hand, does a much more extensive quantization process, has much more in-depth algorithms, and it does take a lot longer to run the quants, but they have a model zoo of existing ones. And generally, if I have to quantize a model with AWSQ that's like 13 billion parameters, I'll let it run overnight on Jetson AGX Orin, and it performs significantly better in the research stats. In my just like demoing around, normal 4-bit quantization is fine. Oh yeah, the quantized models should be faster, but the devil's always in the details with this stuff. And if you just like dig in to the MLC source code here, these libraries are absolutely massive. And the MLC one is built on Apache TVM project, which is an even bigger inferencing library built on just like normal ML type workflows, and it does pipeline optimization and kernel fusion and like all this advanced stuff. But this stack is just built on like millions and millions of lines of code, which is why like my containers for this end up being so huge in size. And you can see here, like these are all the different major packages that I have support for, in particular to the LLM sphere. And this local LLM one is basically a wrapper around a lot of the highest performance ones. And trying to find all the image tags here. Yeah, these images are quite large. This is the compressed size at 10 gigs. When it's uncompressed, this is like a 22 gigabyte container image. And that's even when I like just make the deployment version, because it has so many binaries installed and so many libraries. It's actually insane that we're like able to get this all working with like all the libraries. There underneath it all, there's very accelerated Cuda code like Cutlass and Faster Transformer and Flash Attention and all of these optimizations that go in there. And that's what gets you from, 5 tokens a second, 10 tokens a second, up to like 50 tokens a second. We've calculated that with like MLC, we've approached more than 95% chip efficiency. So like it basically can't go any faster. You're at like the limits of computational memory bandwidth and things like that. And that's why quantization continues to play a factor. Okay, before I get too far ahead of myself here, let me check out the chat here. Are all Jetsons using unified memory? Yes, they all do. They all have a shared system RAM with GPU memory. It's all the same physical RAM. The memory controller is all the same. The Cuda APIs, you can get the shared pointer to both. There's Cuda malloc managed, which will just give you back one pointer, and like it will internally handle any memory copies necessary. And on Jetson integrated GPU architecture, there are no memory copies necessary. There's still synchronization needed, so that like GPU and CPU aren't working on the same memory at the same time. But yes, all Jetsons since the beginning, since TK1, they've all been unified memory architecture. The extent to which the APIs have caught up with using that software support are have gone on more and more. And speaking of that, I get brownie points to anybody that can find the reference of my background image that I have going on here. If you've been around long enough, you might remember what it's from. And I'll give you a hint. It was from the TK1 launch, actually. And they made this. This was before I worked for NVIDIA, actually. They made a crop circle, and the marketing tagline for it was impossibly advanced. And I was just thinking the other day about how TK1 was actually like very formative, because that was the first Jetson that you could actually run Cuda on. And ever since that, we've been able to leverage like these huge open source projects that use Cuda acceleration in the ecosystem, mainly for discrete GPU, and are just able to like recompile that and tune it and get it to all run and be able to leverage all of that work that everybody else is doing. And by virtue of that, I'm able to have all of these container support in here. And this is like the entire list. It's gotten a little out of hand, to be honest. I need to call this back a little bit, because it turns out maintaining all of this stuff over time is really a big time sink. For example, the Ooga Booga one loves to fail to build because it pulls in everything. Well, except for like the fastest stuff. It pulls in transformers and llama.c++ and xllama and auto AWSQ and all of the different APIs. So that like container takes a while to build. But if you're wondering like, why do I even go through the trouble of doing this? It's to assure that all of these packages are built with CUDA acceleration enabled, and GPU is still working in it and everything, and there's no conflicts there. Because, for example, as I'm sure probably many of you have found out, if you just like pip install Torch, it will install the CPU only version on arm because pip doesn't know that you're on GPU. Okay, it doesn't know. It just detects that, oh, you're on ARch64. I'm going to install the pip wheel for ARch64. That was only built with CPU enabled because it's what's in PyPy, versus these other wheels that you like download and install like from the PyTorch for Jetson thread. This is like the longest running forum thread in existence on like the forum. It's actually like the second most popular forum topic. Let me see if I can get this. How do I dismiss? There we go. It's actually the one of the most popular forum topics. But basically, you go in here, pull the wheel, download it. But the other packages love to uninstall these because they'll specify a particular PyTorch version, and then when they pip install it, uninstalls that one and everything else. And so I have these extensive testing scripts in here. Every container has one of these test scripts essentially that checks the GPU functionality. And this script runs at both the intermediate build stage and at the end of the container. So when it builds the PyTorch layer of the container, it tests it right after that. And then it tests it at the very end of the build too. So then you know if it worked right after it installed PyTorch, but then stopped working at the end of the final container artifact, some other package uninstalled it at some point. And there are just like so many instances of little patches and stuff that have been applied to make this all work, that some of them need continually updated. A lot of them I try to upstream back into the projects. For example, here's the spaghetti mess that the Ooga Booga one is. And this stuff here is essentially all taking out specific versions of these libraries that Ooga Booga once installed so that it doesn't uninstall the GPU optimized ones that I previously installed. And there's like lots of cases like that. David's saying even up to 13B models could possibly fit too. Not on the Orin, or not on Orin Nano. I don't think that is just like a really tight fit. But I had done a lot of work really recently on small language models and mini VLMs for Orin Nano in particular, to get that more memory optimized. And it was only until recently, like we could always do Llama 7B on Orin Nano, and that'll run at like 16 tokens a second with MLC through llama.c++. I think it's like 10 tokens a second, which is like pretty fine. But it does take up a lot of memory, like more than 4 gigs. And in reality, like your real system memory usage is even higher than that. And you probably want to be running other stuff too at the same time. And it's just like a lot. And what I found is that like some of these smaller ones, like Sheared Llama and Llama and Stable LM3B are my favorites out of these. And they perform very comparably to Llama 7B. I have a bunch of test samples here that you can go through and like run these on your Jetson, just to see, but they do perform very similarly. And this is kind of known that a lot of these high quality SLMs at this point approach the level, if not exceed that of the initial 7B models, because the quality of the data sets has gone up a lot. And I wouldn't go so far to say that these are as good as Mistral 7B, because Mistral's data is like really good, and Mistral 7B is a really good model. But these are definitely as good as Llama 7B is. And it's also kind of accepted in the community that Llama 2 was kind of undertrained given the amount of data. But hey, they're already coming out with Llama 3. I think Jan LeCun alluded to a summertime release for Llama 3. And it's just really great, like these other companies that we're fortunate to get to collaborate with, like Facebook and or Meta, Google's, OpenAI's, all of them that are putting out these high quality models, in addition to like smaller players too, like Mistral and News Hermets I've gotten into as well. It goes to show you like there's all these, like you can really go down the rabbit hole on the Hugging Face Hub about some of these. News Hermets I got turned on to because they started training these mini VLMs based on their high quality fine tunes of the stable LM. So, okay, let's just dig into this, because the whole reason that I started profiling the small LMs was because I wanted to get mini vision language models that would run really well. And I quickly identified stable LM as a good architecture and other derivatives of Llama as a good architecture, because these are very highly optimized. So you might think, oh, you can just go in and make a couple little tweaks to the model's neural architecture and like it'll be better. Well, in reality, Llama architecture has been so heavily optimized. It's just way faster than everything else. Stable LM is very optimized as well. Stable LM is made by the same company, Stability AI, that does Stable Diffusion. And these are really good models that they've come out with, really good base models that people fine tune. So essentially, Stable LM came out with a really good 3B model. Then News Hermes, who has really good data sets, fine-tuned their own text chat model called Capybara on that. There's so many out there, which is like really why you got to prioritize what you're going to try. And then on top of that, they trained a mini VLM called Obsidian, which it seems to work really well. And there are some results here. Like you can just go in this table and look at, sorry, this table's like really big, but there are a bunch of examples here that you can go through and see how it does. And surprisingly, there was even less difference in the output of the mini VLMs than there was in the SLMs. So a lot of these are doing like really, really well, which is awesome because they improve the frame rate really good. This is one of my favorite questions to ask it, is how many miles away, like can it do OCR on this? And the Vela models get it. And we'll talk about Vela in a second, because that is where things are really heading. And there's a brand new Vela 2.7b model out, which is what I've been running and working on. And Vela supports multiple images. So Lava does not. Lava is single image. The stable LM based Obsidian is single image, and we really want to get into like multiple images. So you can do the live Lava, but on like a recurring feed. We're like, what changed from this image to the last one, and then do like event detection based on that. Let me catch up on questions here. Are the tokens per second measured on AGX64? Yes, yeah. All benchmarking on AGX ORAN is on the 64 gig variant, which is like what all the dev kits ship with nowadays. I do not have the perf data for ORAN NX 16 gigabyte, but that is actually, I don't even have one. I really need to get one, and because that is actually a really ideal platform for this, because it has enough memory that you can also run like the OCR, or you can also run ASR and TTS and do like live verbal chat with stuff. With the ORAN Nano, you're not going to be able to fit all of that in. Like, yes, you can do the live vision language models now on that, but it's already consuming like most of the memory of the board. Let's see where we're at here with that. So yeah, if I want to run the latest Lava 1.67b, it's taking up like 5 gigs. So, and considering all the ASR and TTS stuff these days is also transformer based, and like the Riva ASR TTS, that takes up 5 gigs on its own. So the ORAN NX 16 gig is a really nice form factor for doing all of this in. And yeah, I should get one of those at some point in benchmarker. But also like it's just too much to handle like all the data. I'll show you the my actual like private benchmark charts just to. This is like my worksheet with like everything in it. There's so many in here of all the different like experiments that I run, and look at all these tabs. It's like out of control. All of these are, and this is just for AGX ORAN for most of it. I only really started focusing on over Nano more recently, just because like we're going as fast as we can, and this is where we got to currently. So it's just like a lot to do. And also, I really wanted to bring these models down to over Nano. There was a lot, like with the SLMs, each of these different architectures, I had to go in to MLC and make sure they all still worked, and the different quant tools, and every single one of them I went through and fixed bugs for and profiled them. And like, for example, when we started Phi2 and Gemma were like really slow for some reason, and Gemma just like came out, but we like got that optimized, running faster. So like each and every one of these has things associated with it. That's what I'm saying. Like once you get inferencing API and quantization tool that you like with a model architecture, try to like stick with that, like stick with Llama derivatives or stable LM derivatives. Those seem to run the best currently. And so different fine tunes on that. For example, Lava is just a fine tune of Llama. It's literally the same code that runs the LLM portion of Lava, just with the clip preprocessor and projection layer in front. Let's see here. Have we made portable Jetson clusters? Not really. I mean, there's guys in the community. I know if you go on to the Jetson AI Lab projects here, which is like there's been some all. Thank you to everybody who's contributed to these. At some point there was a project about doing this thing. I don't know if I would call this portable. This is from one of the top contributors and early adopters of Edge LLMs, and I think he's on the meeting here today. There is another, I think Seed Studio also has a cluster board for Jetson. Oh yeah, the Jetson Mate, there it was. This is probably the closest thing I would call to being portable. This is a nice little thing that has like 4 SODIMM slots in it for the nano form factor, and you like plug everything in there and off you go. And you can put MPI or whatever on there. Can you attach a discrete GPU to the Jetson's PCI Express port? Yes, technically you can plug one in there. The drivers won't work though, because the Jetson still uses the integrated GPU architecture versus the discrete GPU drivers. For example, in Ubuntu, do not do the normal driver install like NVIDIA driver -580.32 or whatever, because it'll just mess up all of your drivers. And this is like a long-term thing that we've been working on for years, to like merge the iGPU code paths with dGPU. And you see this with Jetpack 6 starting to come to fruition, with how we've upstreamed most of the Linux kernel patches for Tegra and have the GPU driver now running in its own loadable module. So like the next step after that is to merge it. And then hopefully, yes, you will be able to do that. But also like that's not at the top of mind for like our support, because that's not what you're going to be doing in the field. There are larger systems called IGX that are for industrial use cases, and it's essentially a Jetson plus like an A6000 GPU that's industrial related for like factory floors and stuff, and that you can get. But like just plugging it into putting a 4090 card or whatever onto your Jetson, if you're somehow powered, that is not an actual embedded use case, and we have to like prioritize our support for those things.
Hey everybody, hang tight. I know there's some technical difficulty. I was watching the stream myself. Probably something on Dusty's end. I'm sure he's kind of restarting the StreamYard app right now. So hang tight. So he gave a nice pitch for GTC earlier. So everybody's registered. It's going to be the great place to not only watch some engaging sessions, but also a great event to meet people, not only NVIDIA developers, but other community developers, partners. There's a great app that recently launched, GTC app. There's also another meeting app that's coming out in the next coming days. So it's a great opportunity for you to meet with other people who are doing similar projects. We also have an ad event calendar. I'll put it in the chat in 1 second. So if you are interested in other upcoming events, we're really happy to see the Jetson Gen AI team launch this community meetup. So great participation in the chat we're seeing today. So it sounds like this will be an ongoing series with your participation. That's always fun. And we actually have, if you're interested, we also have a developer Discord, which is NVIDIA Developers, I think is the name. If you go to the discord.gg/NVIDIA Developers. Dusty just sent me a message in the background, so he's coming back in 1 second. So I'm just going to hold the fort here. Really good to see. I'm curious where everybody is connecting from. So in the chat, let me know where you are from, what part of the world, and if you are planning on coming to GTC, that would be awesome. And I think I see my colleague here. There he is.
The power literally died at my house, and of course it reset the Wi-Fi router. I'm sorry.
That's what makes live streams so great. You never know what's going to happen.
Thank you, Emma. Of course, it like never goes out here. So sorry about that, everybody. Thank you for staying on. Thanks, Edmar.
Yeah, I'm gonna post a couple links in the chat, so I'm just gonna go to the bottom of the screen, Dusty.
Oh, okay. Yeah. Hopefully that's it. Maybe PowerPoint was doing something. Okay. Let me reshare my screen. Where were we? It made me realize that I didn't even get to running the demos that I really wanted to show you guys, and now I'm gonna have to restart those, so you'll get to see all of the gory details. Okay, so that power cut made me realize, like, let's prioritize what we want to talk about here. So the new Vila VLM, right? It comes out of the same Song Han lab at MIT, and he's been really great to collaborate with everything that they've done, and they've moved to training these advanced vision language models on high quality data sets called Vila, which were just released recently a couple weeks ago, including a 2.7B mini VLM on it. And these support multiple images. Here's a demo of this running on multiple ones. Here's a cool example. This is running on, this is not my board. This is running on an over and somewhere else. Let's see if they might be actually like working on it right now. This does not look like this earlier. Yeah, they must actually be developing it on the back end. But you can see some examples that they have here of the multi-image support. For example, you can tag the different times of, let me zoom in on this here for you. You can tag the different times of the photos, and it'll infer and tell you, oh, I did so-and-so at this time, because it can actually do multiple images in the chat context versus Llama, which can only do one image at a time. And you can also do this for, use this for doing change detection or other things like that. And the really nice thing is these models perform, they hit above their weight. For example, the Vila 2.7B acts like Lava 7B, and Vila 7B acts like Lava 13B. And we can see in the benchmarks here how these do. So yeah, on AGX Orin on Vila 2.7B, I can get up to over 2.5 FPS on like a yes/no question. Like, is there a person in the video feed? Is there smoke or fire, or things like that? And this is not linearly increased from there. Most of the time in that 2.5 FPS goes into just the pre-processing of the image, because each image is basically 576 tokens using the clip 336 resolution vision encoder. And so those 576 tokens in your context line take, most of the time in that. And then from there, they can output at their token per second rate. So you can essentially just take this FPS and then add on the number of tokens per second that you want it to output additionally. And then that'll give you a gauge for it. But even like little over Nano can do this at 1 FPS. And yes, it's not like 30 FPS like YOLO would be, but the level of detail that you can get out of this, and also just like the user program, this is essentially like a smart AI camera that anybody can program with their voice just by like speaking a query into it. Yeah, power cuts normal for edge problems. Yeah, I should have like battery backups going on here. But okay, let me see if I can restart this and show you it running. I've essentially been adding a web UI to this live Lava project and putting some like more bells and whistles in there. So let me pull up the command to restart this thing here. Now you get to see all the code that I'm working on too. We're just all over the place here, aren't we? Let me see. Is this the one? So I have this like scratch pad that has all my container launch commands in it. I think this was the one. All right, so first we'll start this local LM container, which is built on MLC and AWSQ and has all the most optimized APIs in there, which are unfortunately not supported in like Ooga Booga and other things like that. So if you don't need the absolute maximum best performance, no, you do not need to do all of this. And did my video device change since it's rebooted? Let me see. I think it probably did, yeah. Okay, thanks for bearing with me here as I get this restarted. And if you do come to GTC in the labs, it'll be much like this, where we're going through, and these commands are also documented right here on like this page. It's like the same things that I'm running here. Let's hope this starts. Looks like it is. Okay, we can see it running there. Let's fire up the web UI for what's this? Well, 192.168.186. What's the port? 8050, I think.
Okay, looks like we may have had another power outage from Dusty's side. So hang tight. Oh, here he is. He's back.
It takes a crazy day to have such IT issues here, unfortunately. But look, okay, so it did start. And here we can see it running through the web UI for this, which is basically the same thing as like the live Lava was before. But now you can like change the prompt and do things in our head, so you can set alerts on this. And this is at an increased rate. We can see now that it runs faster than it did before. And this is a rate, the rate is dependent on the length of the output. So it is non-deterministic in that fashion. And you can set the maximum number of tokens you want to generate based on that if you want to limit it at the upper end. But let's see if I can just start setting some event filters here for this. And you can see now it basically searches for these strings, any combination of, this is just like real basic stuff. You can either do or ands in there, and it'll start setting the filters off based on. So now it's like, oh, the man is not in the feed anymore, and now the man's back. Or let me do some other ones for you.
Wild.
It is like super fun to play around with. So we can like do like the OCR. Oh, here's a fun one. Okay, so let's set an alert to detect if, like a smoke detector, basically. Here's a, and you can see here, it like triggered the alert for you. And this alert thing at the bottom is just a proxy for, like, you would hook your actual code into this alert subsystem from here and trigger whatever you needed to. Call the fire department or whatever from that. And you can see how you can code this to do anything. And yes, this is all still very much like work in progress. I think there's like some image pre-processing stuff I need to explore. Like, is it doing cropping? I think it's still like cropping the image on me, and I need to figure out if like resize works better, or like what I need to do. So just like playing around with these different models and profiling them. And it is assumed that at some point that it might have died in the background. Let's see what happened here. Yeah, the terminal. And but yeah, this is, we're getting there with this stuff. Eventually I'm going to hook it into like the RAG system that we have, like this Nano DB project. That's what I'm going to work on next, actually, is reusing the clip embeddings that come out of the VLM to index against a database that you have, for example, MS Coco, or your own personal database where it's like you tagged it with like, here's Dusty, here's like my daughters, or different rooms in the house, or whatever, and then it'll automatically pull that up for you, which then you can use to do multimodal RAG with. So all of this is like highly experimental. Don't get me wrong. All the code is fully open source for this, including MLC and all of the, like, you can, if you want to look at the vision agent that I'm running with all this, you can literally just go in and change it yourself and start playing around with it, and yeah, start hooking it all together. This is the video query one. So this is what we were just
question
running.
in the chat from Rich. Let me see. I put it on the screen here. Have you tried this with low light images or thermal?
That's a great question. So I've had some. I installed some like mini cameras around my house to do RTSP, just because I don't have a security system and I kind of need one before I go away for GTC, actually. And I've had mixed results with like the IR, because the models weren't really trained on that data. Okay. And that does go to speak to the bigger thing with this. Eventually you want to take this into production, you will probably have to fine tune your own model on it. And the good news is that is not as hard as like it used to be doing these LoRa's. And there's lots of people that are training these vision language models. There's this one called Bunny that just came out, and just like ordinary folks, researchers are doing this. The Lava, for example, was trained on in just one day on, I think it was like 8 A100s. So you can rent that for, I don't know how much it would cost. It could probably be a couple $100. I don't know. It's not an insignificant amount of money, but also if you're like serious about deploying this, it's also like quite attainable. Right. Most of the work will all go into curating the data set. But then again, you might already have that. For an example, if you want to train a VLM on like a conveyor belt system to like sort stuff, you might already have all of that. And it's just simple yes, no, like, do I need to sort this package this way or that? And the data set can be simple there. And you can just run it through the Lava training script, get cluster instance on AWS, or I think a lot of people use like Paperspace or these other spot clusters where it'll just give you like the cheapest one. So there is a lot you can do with it. This is all the demos that I've showed are very much like a starting point. This is all like very bleeding edge, all the latest packages that are in there. I'm like recompiling all this stuff on practically like a daily basis, and to get all the latest model support, which is how we're able, like Gemma just came out like 2 weeks ago, I think, and it was the very next day that we were able to run it optimized, fully quantized, and be able to deploy that. But it'll take months to actually get it into real world stuff. Let me scroll back through, and thank you, Edmar, for posting the GTC discounts and stuff.
Yeah, of course. Great to see people there.
Yeah, I want to make sure with the time that we have left, I didn't miss anybody's. Yeah, here's a funny one from Michael. I remember the original Jetson with the Tegra 3 or 4. Yeah, and that was like way back in the day, but before I was with NVIDIA. But even then, I still was doing like embedded GPU stuff. And when it was with Tegra 3 and 4 and pre-CUDA, we were all doing like OpenGL shaders for optical flow and stuff like that. So people like always find a way. And it's the same thing with like this embedded stuff. When we first started in the summer, everybody's like, why are you even doing this on the edge? Just like run everything in the cloud, do everything through OpenAI's endpoint. And that's all great and everything, but you're unable to achieve these like interactive, low latency, like literally playing in front of it, talking to it. I remember the first time that I spoke to Llama back and forth through this Llama Speak demo, and it was like really something, because I told it, I was like, hey, I have a video of this somewhere on YouTube where it was like the aha moment, and I told it like, hey, I gave you a voice and ability to like hear and stuff, and it got so excited about that. And then I told it I was going to give it a robot body and be able to run around, and then it got really excited at that, and then started wanting to project manage me about like, well, what are the timelines for this? What are the action items? Can I like help you out with like the engineering, which was really funny. And again, this is all like, it's like kind of a canned response, but it was like pretty authentic, and it was cool to really see this stuff come alive. And like, not even to mention all of like the security concerns and low latencies. Yeah, Blip too. There's been some really foundational models, and with the vision stuff, it's almost all derivative from Clip. Really, is what a lot of this stuff comes from. NanoOwl also was built on Clip, which is like, if LLMs are too much of a stretch and you're not even like getting into those or vision language models, this NanoOwl is a good intermediary because it's object detection but open vocabulary. So you can basically do the same thing, type in what you want to search for, it'll give you the bounding boxes back. And this runs at 100 FPS, but it only gives you bounding boxes of certain items that you're looking for. It doesn't give like context, like what am I holding and what does it say, or what time does the store close, if you like give it an image and expect it to do contextual reasoning on the OCR, things like that. But all of this, like everything everything is going towards transformers and attention based, as opposed to CNNs. We're even starting to see this in like time series based networks. So yeah, there's been a lot of these like really foundational models out there, and the training of them is still always evolving over time. Everybody's data sets, these models are essentially a proxy, a compressed proxy for the data set that they're trained on. So that's all super important. And I would like to think we've like kind of caught up with state of the art research on like the deployment side and like getting this stuff into real world embedded applications. But as soon as I say that, some new awesome whiz bang model comes out that is like revolutionary, and everybody scatters to get it supported. Yeah, Dino is also a really good foundational one. They're just like way too many for me to like personally look at there. That's why I like to organize the Jetson AI Lab here by essentially APIs. So with everything that's available on Jetson containers, which is Jetson containers essentially backs all of the tutorials on Jetson AI Lab and provides all the code for it. if you can load it through Ooga Booga or Llama.c++ or any of these other ones, then it's like good to go. You don't need specific model support unless like it needs to be added to Llama.c++. And then that's kind of like their problem to do. And like we collaborate with them and file bugs to like get it fixed and then rebuild our containers when we need to. All right. Thank you everybody so much for joining us. I'm sorry about the power cuts. I'm definitely putting a UPS on my router after this. But this was great. We will do this again if you guys like this, maybe after GTC. And is there any plans to provide a llama.c++ backend for Triton? I don't know. I don't personally use Triton Inference Server. I know it's very good for like production, right? And like DeepStream, Riva, TensorRT LLM, those are all based on Triton. So a lot of the stuff I use inherently uses it. I don't know, and you Google search with what I do. I don't think internally, like NVIDIA engineering teams are not focusing on llama.c++ because the performance is just like the gap's way too high. We are not, dedicating engineers to working on that project. Those are all going into like TensorRT LLM and things like that. In addition to all the other libraries that we put out there, like faster transformer and these Cutlass. Cutlass is a very popular library. It's essentially replaced cuBLAS because Cutlass is like the templated version of cuBLAS, where let's say I need a matrix multiplication in FP4, like 4-bit with such and such dimensions. It'll compile it for that particular config that you need for like the Llama attention head or whatever. And then it'll be way faster because it is able to code gen it at that time. So we put all those tools out there. Those get adopted downstream. Then eventually, like we circle back and like compile those all so like you guys can use this. But in general, like this stuff is like I'm not authoring llama.c++. I just compile it because it can be a pain in the neck for everybody to do, and like I like to help people out like that. All right. We got 2 minutes left. Unless there's any final questions, I thank you all for doing this. Oh, before the power cut the first time, I was going to go and say I've been working a lot on NoNano because of this Hackster competition that we're running for Gen AI and AI innovation on there. And so it's really great to enable mini vision language models, mini LLMs for the folks participating in this, because now you can enable that in all of your projects. And if you guys have cool projects out there, like the ones on the Jetson AI Lab, like we started listing some awesome ones here on the homepage. Thank you to everybody that's already here on the stream that's like contributed stuff like this. These are great to go and look around. So if anybody that comes up with cool stuff, please like ping me and I'm happy to feature on here. And you can submit it to this Hackster competition, which has like over 50K worth of prizing. You can get your 4090 or whatever from here and then train your vision language model or Llama fine tune on it and go off and deploy that and go and change the world. So all this is going to really have a huge impact on things. And as like the edge people, we are fortunate to get to integrate that into like actual real world use cases. And you will start to see things really start to come alive. So it's been super exciting, like dedicating my career to working on stuff like this, supporting the community and having you all go off and embrace it and go out and build those things on top of it. And I'm really very appreciative, and it's been an honor to support you all through this. And I appreciate collaborating with each and every one of you. All right, with that, I think we'll call it quits for today, but we'll do this again next month if people are into it. And let me give you the link. Here we go. Link to the competition. Thank you guys. Thanks.
Thank you to Dusty, to you also, and the team for doing this kind of thing and be able to
I appreciate like the informal format because to be honest, like
Great.
we've all been working 24/7 to get ready for GTC and all these demos and everything. So I just thought I would show up, show you where I'm at with things, where I'm heading. And yeah, it seemed like even in the past couple of weeks, like all of the different parts are really starting to come together. Like we have the mini vision language models trained. We have the optimized architectures in the inference engines. We have the multimodal vector databases. We're now, and we have the web UIs. We're now able to like pull that all together and really make an intelligent visual agent that can like do things. And it's super fun to play around with in real time. All right. Thanks, everyone. That will sign off. Thanks, Edgar. I appreciate
Thank you.
it.
Thanks. Thanks,
All
Dusty.
right.
Bye.